So good evening and hi to madam. So we're from group 2 and now we're going to present about our histology workflow. So I'm Damia and I'm going to present about the introduction. So histology is a microscopic study of tissues and it is widely used in biomedical, clinical and forensic labs. The workflow begins with specimen lodging and grossing followed by fixation, processing, embedding, sectioning and staining. So first, specimen lodging is the first step of the workflow which ensures proper identification of the specimen, and the specimen container must match the request form. And essential details are recorded and each specimen receives a unique accession number labeled on containers and cassettes. This ensures reliable tracking through processing, embedding, sectioning, staining and microscopy. So next, for mice dissection, a laboratory mouse was euthanized using cervical dislocation, an ethical and approved method. So the mouse was then placed on a dissecting tray and major organs were identified and collected. So next, for tissue grossing and fixation, after extraction, organs were grossed by observing their size, colors, and textures, and grossing ensures tissues are trimmed to suitable sizes for sectioning. And the organs were then fixed in 10% neutral buffered formalin at the ratio of 1 to 10 tissue to fixative. So fixation preserves the tissue structure, prevents autolysis, and stabilizes cells for processing, embedding, microtomy, and staining. Next.
The fixed tissue will then undergo tissue processing, which requires only simple equipment for manual processing. Some high-volume laboratories will utilize automated processor. The first stage of next slide. The first stage of tissue processing is dehydration, where the water in tissue is removed and replaced with gradually increased concentration alcohol from 70% to 100%. Then the tissue is cleared with an intermediate agent that is immiscible in both dehydrant and embedding medium like xylene. In the last two stages, infiltration and impregnation, the tissue is immersed in molten paraffin wax for a few hours because wax can provide support to the tissue during sectioning. Next. After tissue processing, the specimen is transferred from thermal unit to dispensing unit and embedded with molten paraffin wax in a suitable size of metal-based mold. Next. Once the orientation of tissue is fixed and covered with cassette, the mold is cooled at the cooling unit and the wax is solidified to form a solid block containing the embedded tissue.
So hi, my name is Jacklyn. So I will talk about the sectioning, fishing, and staining. So first of all, before we go through our sectioning, we have to turn the blocks into trapezium shape, like the picture. After that, we go through sectioning. We have to grow the block first, then we have to section next. Then after section, we will form a nice pretty ribbon just like at the end of the pictures. Next, then after that we go through fishing. So fishing, we have to place the ribbon into the water bath. Then we have to fish it using the slide. After that we place it on a hot plate to let it dry. Next please. Then after that we will go through staining. So in the staining stages we have to go through deparaffinizing, dehydration, hematocyanide staining, eosin staining, and dehydration, clearing and melting. So next we have the end of it is melting. So we're using DPX. So the DPX, we just use a drop of DPX and then we place it on the slide. After we cover it with this cover slip, then we just leave it air dry and we're going ready for our microscopic examination.
My name is Teo Xin and I will be talking about the microscope slide viewing. The microscope is set up with the adjusted illumination and the slide is handled by the edges. We start with the 4x objective lens and use the coarse focus, and later move to a higher magnification lens and use the fine focus. And the observations are photographed and measured and recorded. For microscope handling, the slides should be held by the edges with the lens cleaned with the lens tissue only. And for 100x magnification lens, use the immersion oil for clearer optical visual. So for the results, the brain, we can see normal cortical layering and clear neuron clusters. Next. For large intestine, the intestinal glands, the clear glands can be seen with tall columnar epithelial as well as distinct epithelial cells and goblet cells. Next. And in general, for large intestines, there is an intact mucosa, straight glands, and many goblet cells with no villi. And lastly, for liver, you can see there's normal hepatocytes, plates, and sinusoids. Next are the artifacts that can be seen. For spleen, there is fragmentation where the tissue is broken into pieces and uneven borders. It is caused by rough trimming, poor fixation, and paraffin was too cold or too warm. Next, for the brain, folding can be seen where overlapping tissue layers occur due to improper water bath stretching or low bath temperature. Next is the liver with a DPX mounting artifact with dark smudges caused by too much DPX and dragging during cover slipping. And lastly, for the brain, there will be overstaining where the tissue is overly dark, which obscure the details and caused by prolonged staining and poor timing control. For slide labeling, recording and reporting, it is important to include the name, the identity number and the date, and to record the magnification and structures, colors, staining effects and technical details. Proper documentation ensures traceability and prevents misidentification, and the reports must be clear, objective and describe the architecture and abnormalities. In conclusion, the accurate histology depends on proper processing, staining, mounting, labeling and documentation. A good workflow prevents artifacts and ensures high quality interpretable slides. Thank you.